So in today's video, we'll be learning about rational numbers. So a rational number is going to be a number that you can write as an integer divided by another integer, or the same integer, it doesn't matter. So you might be wondering, what is an integer? So an integer is going to be a whole number. So for example, it's going to be -6, +1, and 0. Those are whole numbers. So it doesn't matter if it's negative or positive. As long as it's a whole number, it's an integer. So to determine that, let's say we have a number like 7. How do we know 7 is rational? Well, we need to write 7 as two integers, so just a positive whole number. So we can write 7 as 7 divided by 1. 7 divided by 1 is going to still give you 7. So we didn't change the value, we just changed how it looks. And we can also write it as 14 divided by 2. We can do a different form. And then we can go so on to 21 divided by 3. So there's many different ways you can write a rational number. As long as we use integers to make the fraction, it is a rational number. Now, how can we write 0 as a rational number? Well, we can write 0 as 0 over 1. 0 and 1 are integers. We can also write it as 0 over 2. 0 divided by 2 is still going to give you 0. And we can go to 0 over 3. So those are the different ways you can do 0 as a rational number. Now, how can we write -8 as a rational number? Well, we can do -8 divided by 1, which is still going to give you -8. We can also do -16 divided by 2. That's still going to give you -8. And we can also do -24 divided by 3. Now, there's two properties regarding decimal places of rational numbers. So there's one property called terminating, which means the decimal place ends at some point. It stops. So let's say we have a number like 3.01. 3.01 ends at the 1 decimal place. So this indicates that it's stopping. And then the other property is called repeating decimal place, which this means that it goes on forever and it repeats a particular pattern. So like 1 over 3. 1 divided by 3, if you put in your calculator, is going to give you 0.333 and so on. It's going to repeat a pattern of 3. It's just going to keep repeating 3 forever. So in mathematics, sometimes they'll use the notation of a line above the numbers to indicate that the number is repeating forever. That number that it's below is going to be repeating forever. So let's try a couple numbers. Let's see if we can determine what decimal place properties they have. So let's say -5 divided by 7. If we put -5 divided by 7 in your calculator, you're going to get -0.714285. And it's going to repeat. If you have a calculator that can take in, or that can produce out those amount of numbers and give you a long amount, more than just what I gave you, you're going to see that it's repeating on forever. Now, sometimes your calculator will round up. So mine went to -0.714285, and then it did the pattern again, but it rounded up 3. So here it would look like, oh, it's not repeating because there's a 3 right here. It followed the pattern, but then it got the 3 right here. But your calculator will round up sometimes, so make sure that you're able to determine the actual form. So we have negative 0.714285. I'm going to indicate a line above it to show that this is going to repeat on forever. So this is going to be a repeating decimal place. Now let's try another number. Let's try 15 divided by 3. 15 divided by 3 is a rational number. It's an integer over an integer. But 15 over 3 we can write as 3. Now 3 doesn't have any decimal places. It just stops at 3. So therefore, it's a terminating, or it has terminating decimal places. So that's going to be your answer. Now for the last one, we can do 13 divided by 25. 13 divided by 25, if you plug it in your calculator, you're going to get 0.52. Now notice that 0.52, that 52, it doesn't repeat that pattern. It stops at this 2. So therefore, it's going to be a terminating decimal place.